And welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. Smasher Mash, coming at you from the Smash News Network, least busted name in news. Don't mind us, we're just bringing you the most comprehensive space weather and detailed solar imagery you'll find in the known universe. You may have noticed a massive prominence and coronal mass ejection happening yesterday. We'll tell you all about it. It's from the northwestern limb right up here. And if you're looking for some fresh images of it, I think we can probably facilitate that. So that happened around 2000 Universal Time yesterday evening. Here we've added 193 angstroms to the ionized helium 304 angstroms wavelength from SDO. And how about if we remind you to press like, subscribe, share, etc. Tell your friends and foes about the channel. We don't believe YouTube recommends the content. We've just been producing videos like this for pushing 6 years now. So thanks to everybody who has subscribed and tolerated the ridiculous, nonsensical, pointless, and pathetic censorship on the YouTube platform. Make sure you visit our playlists. Also, you'll find videos not related to space weather or ones that are even poking fun at some of the nonsense you'll find on the internet. Press like, subscribe, share, etc. Visit the links in the description to support the channel. And here we go. Some slowed down imagery of that prominence there in the northwestern limb. That's 4 hours. That's 2000 to 2400 Universal Time yesterday evening. Here's a little closer view. Fantastic contrast there achieved by those wavelengths. Some of that plasma splashing back down, some of that plasma headed out through the solar system. So flaring's been kind of low since yesterday. We slowed this down to 10 frames per second there. Flaring's been kind of low. We do have one new sunspot in the northeast. We'll get to it. Great magnetic loops there featured. And here we've put 211 plus 171 angstroms together. Another fantastic couple of wavelengths there. Wow, that is good stuff. See those magnetic loops there. And there you see a bunch of plasma succumbing to magnetic fields and defying the massive gravity of that star. We'll let that play through one more time here. How you like them apples? That is pretty freaking sweet. All right, so let's move on here. This is yesterday plus today SDO intensitygram, and these sunspots have been largely stable. I would note that this group up here is huge and very magnetically complex, also lopsided. This group down here is also huge and magnetically complex. We've also got a number of sunspots here setting toward the northwestern limb once again. So we do have a fairly high likelihood of large flares here. We'll show you the probabilities a little bit later in the video. First, the SDO colorized magnetogram yesterday plus today. March 7th and 8th. So lots of sunspots there. Not a lot of flares. And we have seen the coronal hole high-speed stream subsiding as well. We'll get to that a little bit later. First, we'll go over volcanoes. Sakurajima continues to erupt and produce a 7,000-foot ash plume. Subanosejima, 8,000-foot ash plume. Dakono, 7,000-foot ash plume. Kilauea has calmed down, so not a lot of glowing happening at the Halema Uma'u crater floor there. It seems like Kilauea is starting to calm down a bit. Popocatépetl exploding in central Mexico, flight level 200, 20,000-foot ash plume, 15,000-foot ash plume from Fuego in Guatemala as it explodes, and intermittent puffs from Sabancaya in Peru. Next, looking at seismicity, and we have seen an uptick in earthquakes since yesterday's report. Lots more earthquakes than we reported yesterday. However, only one of a 6+ magnitude. That was a 6.0 at 13:51 Universal Time yesterday afternoon at Papua New Guinea. So once again, I would state that, remember, folks, any earthquake can be a foreshock. So just be aware of that. You see a big quake, it might not be the end. It might be a foreshock to an even larger event. So there's also a 5.4 there at Indonesia. Also a 5.3 at Papua New Guinea there. That one's an aftershock. So lots more quakes here, especially around the Pacific Rim. There was also a 5.8 at the Kuril Islands there, south of Kamchatka, and a 5.8 at Papua New Guinea. Fiji had a 5.3. That was nearly 500-kilometer estimated depth for that Fijian quake. And let's get back to space. This is, now we're showing 171 plus 131 angstroms. One of the new composite favorites. And let's talk Turkey. Oh, and a quick reminder, consider becoming a member of the Smash Team if you enjoy the content. You like the videos, you'd like to see them continue to exist, remain publicly visible and free for all to view. Consider becoming a member of the Smash Team, especially at the gold or silver level, thanks to our Smash Team gold and silver level. There's also a bronze level if you're unable and or unwilling to open your cobweb-encrusted wallet and send us a few bucks per month. Smashomash.com/Smash Team. We launched our own subscription services site back in October of 2021 because we needed additional capabilities. So we got them. Shout out to Smash staff. Give her a raise by becoming a member of the Smash Team. Also, sign up for email alerts if you want to see when we actually put out a video. Also, disaster alerts do come out typically before USGS comes out with them. So consider that. Here's the past 24 hours in 211 plus 171 angstroms. Great at showing the lower and extended coronas here. So fantastic imagery there. Great depth and detail of the sun's atmosphere. And the 10.7 centimeter radial flux here still at 180 solar flux units. So kind of surprisingly low here considering how many sunspots we have. There is the 1-year graph to put it in context. We're seeing a little bit of resistance here at around 180 solar flux units. And if you're wondering what the 10.7 centimeter radio flux is, it's a radio signal that emits from the upper chromosphere and lower corona, so right about here. And that was discovered in 1947 by Canadian radio users. They were using some old World War II equipment, and that's when they noticed this 10.7 centimeter signal. It is a directly proportional data set to sunspot number. So when we see radio flux rise, we see sunspot number rise. There you can see how proportional the radio flux is. Solar cycle 25 versus the sunspot number. Very directly proportional data sets there. When you see a high sunspot number, you see a high radio flux. As far as the space weather enthusiast dashboard, NOAA's forecasts. NOAA forecasting a little bit of geomagnetic unrest later this afternoon and this evening Universal Time. I think you should probably cancel that. I don't think that's going to be likely to happen. Not even sure what the reasoning is. Maybe they thought the coronal hole high-speed stream would last longer than it has. It is already subsiding. So let's take a look at Earth's magnetic moment from space here. We're going to spend a few frames looking at the geospace magnetic environment. This is the past 4 hours of magnetohydrodynamic pressure. The space weather modeling framework uses all kinds of different data sets, from the electron flux to the solar wind parameters, magnetometers, and more. Again, that's the last 4 hours of Earth's magnetic moment from space. Things geomagnetically calm. Here's Earth's magnetic moment from the ground. Also the last 4 hours. This will show you the most likely places to see the aurorae. Also to see rail line, pipeline, and power grid induction, telluric currents. So that's the Earth's magnetic moment from the ground for the past 4 hours. The units here depicted are nanotesla magnetic flux density. Next, looking at Earth's average geomagnetism here. The KP index, that's what it is. It's an average of global geomagnetism. Current condition is KP2, geomagnetically calm conditions, and let's move to the real-time solar wind. Keep in mind, folks, the real-time solar wind is measured outside Earth's magnetosphere out here at Lagrangian point 1. Since you can't really measure the solar wind from inside Earth's magnetosphere, here is the solar wind for the past day. Again, we do see it subsiding here. Current conditions are just below 430 kilometers per second for the solar wind speed. Solar wind density, about 3.3 protons per cubic centimeter. So diffuse and now getting slower. Next, our magnetometers here, looking a little smoother in the past 24 hours. Those are the GOES 16 and GOES 18 magnetometers. And let's take a look at some additional magnetic data here. Here is our top view ecliptic plane field plot. There is a North Pole current sheet headed this way. You can see the North Pole current sheet depicted in green. So there it is moving in beyond stereo A. South Pole current sheet depicted here in red. And we're fairly confident that by tomorrow, Earth will be in a North Pole-oriented current sheet. Just keep in mind the magnetic environment can suddenly change, like a huge sunspot could appear or something like that. At the moment, we're expecting a North Pole current sheet by the time we make tomorrow's space weather video. Next, our line of sight field plot. Solar polar fields depicted here, green for north, red for south. Solar B field depicted in blue. Next, coronal holes. We've got some North Pole-oriented ones rotating in, I believe. There we go. We've got some North Pole coronal holes rotating in here on both sides of the equator. So if you bring up the latest image, there you go. That's from today. So the southeast will have North Pole-oriented coronal holes. Here's the past 24 hours in SGO 211 angstroms. The sector boundary is something like this. These are North Pole. These are South Pole. And now that we've covered coronal holes, let's move to sunspots. Keep in mind these North Pole-oriented coronal holes here will get more well-defined in the coming days, as there will be less coronal plasma there to block their view. They are indeed there, though. Anyway, moving to sunspots, we do have at least one new group. So this group up here, that'll likely get a name today. That'll be 3250, I believe, will be the new one. 3250 just rose up here in the northeast. Let's take a look at 131 angstroms plus SDO continuum. That's the 24-hour video. And again, flaring's been kind of low here. So these sunspots are underperforming a little bit in terms of flare production. Here is just the SDO continuum wavelength. Actually, that's a series of wavelengths. Hence the term continuum. And we're going to move to energetic particles and solar flares and so on. First, let's take a step back and take a look at cosmic ray flux. So we do look at it at least once a week on the channel. We've seen some interesting aspects of cosmic ray flux here. So let's start out with DOMB Antarctica's cosmic ray monitor. And it's missing data here for the past 5 days. However, it is showing a downward trend there over the past 25 days. That's DOMB Antarctica. Here's DOMC Antarctica, a similar graph there, downtick over the past 25 days. Hopefully they'll get those back online soon. Next, going way up north to Oulu, Finland. And interestingly enough, we see a large range here. and actually a little uptick in cosmic ray flux there over the past 30 days at Oulu Neutron Monitor. So that might have not been expected for you. Keep in mind we are approaching levels here overall that are lower than the previous solar maximum. So another indication that solar cycle 25 is a much stronger solar cycle than solar cycle 24 is when this cosmic ray flux definitively drops below this point right here. That will be another indication that solar cycle 25 is a strong cycle, not a weak one. Let's go south from Oulu to to Mexico City here. There's your Mexico City cosmic ray monitor, and interestingly enough, an uptick there as well over the past 30 days. A little uptick at Mexico City. Let's go farther north now, back to across the pond to the Athens, Greece neutron monitor. And that's got some missing data at the beginning. However, for the past 23 days, a minor uptick there at Athens also. Last but not least, let's go to Apatity and Barentsburg, going way up north. And Apatity showing an uptick in cosmic ray flux the past 30 days. And Barentsburg, a completely different graph there, a significant downtick in the past 30 days, with a large spike there right around February 7th. Anyway, overall, we're looking at flat to upticks in terms of cosmic ray flux the past 30 days. Let's take a look at some more local data. There is your GOES proton flux. That is the relativistic particles as measured by the GOES 16. And those are solar energetic particle events. If we do see spikes in that at the moment, things are quite calm with the GOES proton flux. Next, looking at solar flares, and we just had an M-class flare earlier this morning. It was a low-grade M-class flare at a M1.19, and it did come from that large sunspot group that's right in the Earth-facing zone. So let's take a look at that. It came from this sunspot right here. That's a 24-hour 94 angstroms SDO video. You see right at the end of that loop, you'll see this area brighten up. That's that minor M-class flare right there. Next, looking at a star chart here. We're always interested in what's going on overhead. And at the moment, over Lehigh Valley, Pennsylvania, we do have Saturn and Mercury there, leading the sun across the ecliptic. And if you're viewing the early evening sky just after sunset, you will be able to see Jupiter and Venus, the third and fifth brightest object currently visible from planet Earth. Next, your solar system forecast. This is your 1 week forecast. Keep in mind this imagery is not to scale. And if you don't see Nibiru on this imagery, it's because Nibiru does not exist. Here's your 1 week forecast as Earth is in a lonely portion of the solar system. There's where things will be in a week. Mercury and Venus are speeding to catch up as Earth drops Mars and goes to an even more desolate portion of the solar system here, a portion devoid of gas giants and indeed planets in general. If you haven't checked out the merch, please check out the merch. Today's featured product is a term that we made up quite a while ago. So, chart lighting. Yeah, chart lighting. You might see a lot of that on the internet. So let me just briefly describe what that means. Chart lighting. So if you're familiar with the term gaslighting, it's a type of psychological abuse when somebody tries to convince you that events didn't happen the way that they actually did by filling your head with nonsense. And of course, in the realm of space weather, we do lots of market research, and we research what our competitors are saying, and it's not too hard to debunk their nonsense. But what happens is those large YouTube channels, they block people, they ban people, and they mute people in the comments. So you think your comment's being seen, but it's actually not being seen. Meanwhile, they try to convince you that their nonsense was correct. So that's always a delight. Anyway, shart lighting is when somebody attempts to gaslight you, fails, and then just craps on their own credibility instead. So, of course, you see this constantly happening with certain YouTube channels, certainly. And, shart lighting. It's a serious issue. So hopefully you're not falling victim to gaslighting. Next time somebody attempts to gaslight you and fails, tell them, just stop shart lighting. It's embarrassing. It's a verb that we made up. So yeah, check out the links below the video if you haven't checked those out. The government has been shart lighting hard, Mike. So if you visit the links below the video, you'll find our Redbubble shop in order of best selling. We just recently released 4 new designs, including Croissant Earth, which we featured on yesterday's video, and shart lighting, and we'll just have to leave it there. Visit the links below the video to see the rest of those if you haven't seen them. Great products there from Redbubble, and let's take a look at coronal mass ejections because, hey, that's kind of important, right? So that's yesterday's imagery from the George Mason University data feed. And just bear with me one moment, folks. So you should see a significant CME there out of the northwestern limb. There you go. And let's also show today's imagery. That's 106 frames from yesterday. We'll let that play through once more. And here are today's images. Should see like the tail end of that CME there. There it is. And if you're wondering if those are earthly directed, well, the answer is no. Let's show some corroborating data here from Stereo A and from the Soho Lasco C3. So this is 90 frames on each. Please take note of the time and date stamps at the bottom. They are not synced. They are different time frames. Stereo A there on your left. Soho Lasco C3 there on your right. So again, that coronal mass ejection, nowhere near earthly directed. It's way off to the northwest, mainly the north. And here are some more spectacular 24-hour videos. Let's get a little closer. How about even closer? And let's look at just that CME. And that, my friends, is what you call awesome. All right, so continuing on here to look at filaments. So 2 massive filaments here in the southern hemisphere. I mean, we're delighted that we named this one the Brian Keating. And we're delighted that one of our viewers named this one the Nikki Haley. Those are quite significant filaments. If you want to name filaments after living people, follow the hashtag #NameThatFilament. Hashtag #NameThatFilament on Twitter. Make sure you follow us over there on Twitter if you haven't. In fact, it could be the shadow ban capital of the world. Yeah, Twitter, the shadow ban capital of the world. Elon, he tells everybody that shadow bans are a real thing, and then he leaves them in place. What a pathetic joke. People think that Elon has restored free speech to the internet. Hey, everybody, if you're thinking Elon Musk has restored free speech to the internet, why don't you step out of your fantasy land, get on Twitter, and see how shadow banned you are? Yeah, shadow bans. They're a real thing. Twitter calls them deboosting features, and frankly, it is a criminal organization. It misleads advertisers, users, and well, everybody else. Although it's not a publicly traded company anymore, I can't complain about it misleading investors, although it used to. Anyway, major filaments there. And again, make sure you follow us over on Twitter. You'll also find pinned to our Twitter profile the link to the Hemp Lucid free gummies giveaway. So you can still find that there pinned to the Twitter feed, pinned to the Twitter profile page. Yeah, that's how English is spoken. And here's the past 24 hours from SDO 171 angstroms. It's the house favorite wavelength. So let's see what's been going on in the past couple of hours next, before we get to our bonus features segment. Yeah, bonus space weather features. Here's the past couple of hours. And again, this sunspot is looking like it's going to continue with some increased activity. Also, a huge prominence hanging out over here. Huge trans-equatorial magnetic looping happening over here. So lots of stuff going on, folks. Lots of stuff. It's never boring in the realm of space weather. The sun doesn't go on vacation. And frankly, neither do we from making these videos. We've missed about, 4 or 5 days over the past 6 years? And let's move to bonus features. So satellite charging hazards exist once again. We've got both internal and surface charging hazards. They're both minor, though. So some surface charging there around the Central Pacific, and some internal charging around southern Africa, the southern Indian Ocean, and Oceania, and the West Pacific. GOES electron flux here in warning levels for both the GOES 16 and GOES 18. There's the NOAA forecast expecting similar levels of electron flux. Maybe we'll get a little bit higher levels here than the forecast, but that looks about right to me. There's the 1-year chart to put it in context. We're at quite high levels here. And let's also take a look at the F layer where that's measured. Now the GOES 16 and GOES 18 are way above there. They're at 23,000 miles of altitude. They use radiography to measure the electron flux at the F layer of the ionosphere. So let's take a look at the F layer. And feel free to pause the video on this frame if you're not familiar with the layers, the electromagnetic radiation penetration, chemical, temperatures, and densities. So here's the vibrational frequency, and we've got actually massive high-frequency anomalies here at the moment. So megahertz are millions of vibrations per second. And that data, if you want to check it out yourself, is courtesy of Australian Government Bureau of Meteorology. We'll also show the anomalygram, and you can see lots of blue on the map here. Global scale high-frequency anomalies happening in the ionosphere. So a little bit faster vibrations than the 30-day median here. That's what the anomalygram depicts. This is the anomaly in megahertz from a 30-day median. And the cool thing about the anomalygram, folks, is that it's 10 times higher resolution than the raw ionogram. It's showing anomaly in megahertz to the 10th of a megahertz. So it does show a little bit of additional resolution there. And if you're not familiar with looking at the ionogram, it will show you the anomalies, obviously. Anyway, let's bring up the latest image. This is 12:30 Universal Time. Ionogram and 12:30 Universal Time. Anomalygram. Total electron content is next. It's the free electrons between your GPS satellite and your handset. That's a run of about 12,500 miles. The coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Your GPS satellite has to communicate through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. And those free electrons can cause signal refraction, which is what you're seeing here. And we're actually seeing some significant total electron content anomalies here. For example, around the poles. So some GPS errors perhaps happening there in some unexpected locations. We'll let it play through one more time. The total electron content forecast. Next, we'll take a look at the latest new sunspot. So here's your latest high-resolution intensitygram and high-resolution magnetogram. We'll start out with this sunspot up here, this new sunspot that just rose. There you go. It is looking like it's alpha class so far. I only see 2 North Pole umbrae there, so that is an alpha class sunspot, not a magnetically complex one. And again, this sunspot group is the one to watch for sure because it's currently producing some flaring just a couple of hours ago. And there are the fields associated with that. It remains beta gamma delta class. See right here, that's a great example of a delta. And it is a very oblong sunspot. So if you look at the leading umbra here, that's a North Pole umbra. And then back here, you've got South Pole umbrae. So you've got a lot more North Pole magnetism than South Pole magnetism. It's a magnetically oblong sunspot. It looks almost like a flagellate. You know, a flagellate. All right, anyway, here's the full disk rock back. Lots of stuff going on. Massive filaments. Likelihood of coronal mass ejections remains nearly 100%. Likelihood of large flares is very high as well. We'll keep you posted. In fact, we're probably going to do a live stream later this afternoon where we can answer all of your questions. And you'll be able to steer the live stream, perhaps. Live stream coming this afternoon. By the way, once again, don't forget to visit the links below the video. If you haven't seen the homepage, check it out. SmashOmash.com is the official homepage of the Smash News Network, least busted name in news. We built our own website back in 2019 because a crack YouTube unit, namely us, were sent to social media prison for a crime we didn't commit. We promptly escaped the maximum security social media stockade to the internet underground where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. No, you certainly can. Just click the link and you'll get additional content. Check out the links below the video. Once again, in the description, lots of links down there to help the channel out and perhaps help your health out, like our Hemp Lucid products. So check those out. And if you're shopping on Hemp Lucid, make sure you use the promo code SMASHOMASH. SMASHOMASH. Yeah, SMASHOMASH to save some cash at checkout, or just visit via our links. Again, links below the video. If you're viewing the videos on BitChute, make sure you view the videos on YouTube as well. You're missing most of the content. So check it out. We're looking at the coldest place in the world, which might not be surprising to you. It is Antarctica. However, it is summertime down there. Although fall is approaching, we found a spot where it's 67.1 degrees Fahrenheit below zero on the highest and driest continent. Yeah, Antarctica. It's like a big mole on the bottom of the planet. The highest and driest continent. It's drier than any desert. And it's also the highest average altitude of any continent. Antarctica, it is a very weird place. And here's a fun fact. Let's talk climate. Were you aware that Antarctica formed 33 million years? And the ice sheets of Antarctica, they formed about 33 million years ago when the planet was 3 degrees Celsius warmer than it is today. If you're worried about the Antarctic ice sheets melting at these temperatures, well, I would suggest it's probably not going to happen because, well, again, those ice sheets formed when the planet was 3 degrees Celsius warmer than it is today. So that's the coldest part of the planet. What's the warmest part of the planet, you're wondering? Well, it could be East Africa. Over 100 degrees there. How about 110 degrees in Central Africa? Anyway, let's get to our meteorology segment here. We don't want the video to be too lengthy. These are the surface winds of the eastern world. And we'll also show the jet streams. There are the jet streams of the east. Jet streams of the west. Surface winds of the Americas. It's still kind of stormy in the North Atlantic. Surface winds of the central world, like Africa, Middle East, and Europe. Strong low there between the African continent and Madagascar. And here are the jet streams. So that's what's going on. Next, clouds and fog over the Americas. There's our 3.9 nanometer radiation. That's part of the infrared spectrum. We use the 3.9 nanometer to view clouds and fog at nighttime. It's still dark over about half of this map. So that's what's going on with clouds and fog. Great example of a powerful rotating counterclockwise low pressure system there in the North Atlantic. Next, our weather.gov map, and that's what's going on in terms of weather alerts for the 50 states of AUSA, the allegedly United States of America, former nation, now banana republic. You know, where corporatocracy and corruption rules the world. Propaganda, fraud, and nonsense are promoted while facts are suppressed. Yeah, that's what a banana republic does, where there is two justice systems and rampant corruption and zero accountability. Anyway, if your location's lit, click your location on weather.gov. We've got a bunch of warnings in California once again. You're probably getting used to it. And let's look at some forecasts here. This is your temperature anomaly forecast for the next 72 hours based on a GFS model. Things aren't looking too out of the ordinary here, at least for the next 3 days, mostly seasonal temperatures. We'll also show pressure and precipitation for the same model and the same time frame, 72 hours. We show 72-hour forecasts because they tend to be accurate. If you go beyond 3 days, you're probably going to be looking at nonsense. And of course, as those forecasts get closer, we can do more in-depth, detailed analyses. But a 72-hour forecast is fairly accurate. You'll notice that the GFS and the Euro forecasts are looking similar. Look at all the precipitation being pumped in from the Pacific once again into California. Dag. It's a little bit weighted down with water there. I think the drought has ended by now. What do you say? Next, our total accumulated positive snow depth change forecast in inches. And again, we've got some snow coming to Lehigh Valley once again, it looks like here. Another inch or two. And the Boston, D.C. corridor has seen an incredibly low amount of snow for the past 5 or 6 winters. Meanwhile, the past 7 winters have all been record-breaking winters for Northern Hemisphere snow totals. Snow extent has been average. However, snow mass balance and snow water equivalent have been ridiculous. So it's going to be another epic melt season. If we have a sudden increase in temperatures, you're going to see crazy flooding, as there is a lot of snow on the ground currently. Next, we'll go to our windy.com map, and if you don't believe me about the lot of snow, check it out. You got a snow depth map. So one of the great features of windy.com is you got a snow depth map, and look at all the snow in the Rockies and in California and the Pacific Northwest. That is a lot of snow. So it's got to go somewhere, and it's going to go into tributaries and rivers. So anyway, that's the current situation. Let's show the difference between the GFS and Euro forecasts for new snow. That's new snow for the next 3 days on the Euro model. And there's new snow for the next 3 days on the GFS model. Again, Euro model, GFS model, windy.com. They got a great mobile app. Check it out if you've never seen it before. It's free. It's free, unlike these videos, which are done at massive personal risk and expense by Smash Staff and I for the betterment of mankind in order to make Earth not suck again. Again, check the description for links to the merch. If you support the idea of making Earth not suck again, maybe pick up some merch and go tell your friends and foes. Our merch has been all around the world. There are some Mensa products, Make Earth Not Suck Again, all the way down in Tasmania. And this is lightning. And check it out. We've got some lightning here in places like Texas. And here's our real-time lightning map And it looks like we do indeed have some active cells here, which have now moved to the northwest of Texarkana. So between Texarkana and Pine Bluff, Nashville, Texas has got some thunder rolling in. That's not Nashville, Texas. Wait. Anyway, it looks like Little Rock might be in the crosshairs here. That's your real-time lightning map. And thanks for leaving a comment, Jackie2. Good day to you as well. Closing things out with Doppler radar. Clouds and fog over the lower 48 and water vapor. So there's Doppler for the U.S. We'll focus on the lower 48. Some snow moving across Indiana here toward Columbus, Cincinnati, Pittsburgh and Cleveland and Detroit. You're in the crosshairs. Chicago, you can expect some snow to start pretty soon. Here's clouds and fog. And Mike says it is sunny in Toronto. Here's your water vapor map. And we've got that moisture there over Oklahoma, moving into Arkansas, Missouri, Tennessee, Kentucky, Illinois, Indiana, etc. As some cold air is being thrust into eastern Pennsylvania. Anyway, here is where we'll close things out with a recap. That's your U.S. Doppler radar map. There is clouds and fog. The NASA GOES interactive weather satellite. 3.9 nanometer shortwave radiation map. And there is the water vapor map. Hopefully that helps. Hopefully you've pressed like, subscribe, share. Hopefully we'll see you later this afternoon when we do a live stream. And thanks for tuning in. Thanks, viewers. In the meantime, I'll have been your host, Dan, a.k.a. Smash-A-Mash, signing off. And may that solar wind be at your back. Don't forget to visit the links here and here and here.